Hello boys and girls, and welcome to chapter 1 of unit 1 of lesson 1, the very first video of the year. For some of you that know me and have learned with me in the past, you know that I make these videos to help you with your homework. So essentially this is I am your own private tutor at home. These videos serve as a tutoring tool. And what I'd like to do is address and reiterate areas that we didn't have time to do in class, or just additional explanations. For chapter 1, lesson 1, we're going to look at ratios and proportional reasoning. Now, when we talk about ratios, take a look at this example that I have here. We are talking about, it looks like a fraction, but it's not a fraction. Don't get those confused. A ratio is, for example, two different variables and how they are related or proportionally recent. For example, if I have one apple and two oranges, as you can see here, every apple that I have means I will have two oranges. Okay? You can say that the value may be, and this is probably true, it could be true, if you have money, you can either, without money, you can buy one apple or two oranges and it would be the same price. Okay, you could put it like that. So for every apple, you also have the value of two oranges. Or for every two apples, you have four oranges. Or for every three apples, you have six oranges. And it continues on like that. So 3, if you double the 3, let's say you double the number of apples to 6, that means you would have how many oranges? 12, right? I hope you said that. Okay, the ratio of apples to oranges is 3 to 6. 3 to 6. For every 3 apples I have 6 oranges. Or you could say 2 to 4 or 1 to 2. That means for every apple there are 2 oranges. For every apple you have 2 oranges. So the simplest form of this ratio is 1 to 2, as you can see right there. And those are ratios, boys and girls. Now go ahead and turn to page 8 of your workbook. Okay, for page 8, we're just going to go ahead and work through it together, okay? We'll look at number 1, and then at the bottom here, we'll analyze and reflect, and we'll continue on. Now, something important I need to let you know is that this entire page is what we call a key answer, meaning that your answers have to be identical to mine. And you also have to add any additional information that I add to prove to me that you watched this video. This is part of your homework completion grade, part of your formative grading. So just so that I know that you're doing this, make sure when you do this at home, complete it, add a star right here, okay? And you can even add a little smiley face right there, okay? If you have those two things, as well as the exact same answers that I have written the exact same way, that proves to me that you watched the video and you get your homework completed. Great. Obviously, you would have to complete all the other independent pages on your own as well. All right, let's zoom in, turn the camera off, and let's get this done. So let's read along. The ratio of the number of boys to the number of girls on the swim team is 4 to 2. That means that for every 4 boys, okay, there are 2 girls. Or you could even lower and simplify. You could say for every 2 boys, there's 1 girl. Okay? If there are 24 athletes on the swim team, how many more boys than girls are there? Use the bar diagram to solve. Okay, so here's where you're going to write your answer. But first, we have a bar diagram here. This bar diagram is showing us how many more boys there are than girls. And look how they did it. They just drew a bar. They simply just drew a bar, and then they drew half of that bar. You see that, right? Because half of it are girls. See, for every 4 boys, half of the boy number are girls. So clearly you have, these are the boys and these are the girls. So go ahead and write those in, okay? And now I am going to take the liberty of dividing them. So I'm going to divide right here, that is 2 girls, and over here I have 4 boys, right? You see that? Okay, now that's how it's been divided. But the total number of athletes we were told is 24. Correct? 24. So 24 divided into 6 equal parts, right? 24 divided into 6 equal parts. That means per section I should have 4 people. So here. Okay, does that make sense? Now, that means that I have 4, 8, 12, 16, 20, 24. There they are. Okay, so that means that for every 16 boys, I have 8 girls. So use the bar to solve the diagram. What is the question? How many more boys than girls are there? How many more boys? Well, clearly, right here there's 8 boys and girls, but there's an additional 8 boys. And there you have it. Okay, moving on to question 2. Suppose the swim team has 24 athletes, but the ratio of boys to girls on the swim team is 3 to 5. All right, so we've changed our ratio, boys and girls. We have 3 to 5, which means for every 3 boys that we have 5 girls. For every 3 boys, we have 5 girls. How would the bar diagram change? All right, so how would it change? So the boys bar would be shorter than the girls bar. The boys bar would have 3 parts and the girls bar would have 5 parts. That's the way it would change. Okay, now for number 3, we get to create, meaning we make our own real life ratios situation or scenario. Write a real world problem that could be represented by the bar diagram shown below. Then solve your problem. Okay, we need a total of 220. 220 broken up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, I can already think of a number. If you multiply or if you divide this by 11, what are you going to have in each one? Okay, divide this by 11 so that you know what you're going to put into each box. And this ratio is 1, 2, 3, 4, 5, 6. So you have 6 for this ratio, 6. And on the bottom number you have 1, 2, 3, 4, 5. You have 6 to 5, which is 11. 6 to 5, which is 11. So if you divide this number by 11, it'll give you the value that you need in each one of these boxes. Okay, so we were asked to give an example, and here I wrote one out. In Gianluca's cards collection, the ratio of baseball cards to football cards is 6 to 1. So for every 6 baseball cards he has 5 football cards. If Gianluca has a total of 220 cards, how many cards are baseball cards? Okay, so again, this is the ratio we have. You see, 6 to 5, you have 220. I divided it into 11 so that I can get the value of each one. Okay, and then you can just simply multiply that by 6 and it'll give you your exact answer. We will take a look at this answer in class. Please have it ready. Copy this down exactly as you see it so that I know that you watched this video. Okay, for the last question on this page. How can you use a bar diagram to solve a real-world problem involving ratios? Well, let's see. A bar diagram, we use the bar diagram right here. A bar diagram helps us visualize the ratio, 6 to 5. And then it gives us the total so that we see how we want to break up the entire total. So let's go ahead and let's write that down here in the bottom. Please copy what I will write. So we set up a bar for each of the ratio parts as we did here, 6 and 5. Then use the bar diagram to write and solve an equation as we did here. We know that this will equal to 20. Okay, so what's each one worth?